Hi everyone, I'm Joe Cox. I'm President and CEO of the Museum of Discovery and Science here in Fort Lauderdale. And we are absolutely thrilled to bits to be introducing our virtual Camp Discovery. Our mission here at the museum is connecting people to inspiring science. And this is a brand new way that we're connecting you to inspiring science wherever you are. So we're going to explore together, we're going to discover dinosaurs, we're going to make slime, we're going to blow things up. It's going to be really exciting, and none of it would be possible without our incredible sponsors who support us throughout the year to make this kind of programming happening. So thank you, enjoy, and have fun.
Hi, and welcome to Mods. We're keeping you connected to inspiring science with virtual Camp Discovery, brought to you by Citrix, the museum's official innovation partner.
Today, we'll have a smashing good time as we freeze objects with liquid nitrogen and then smash them to bits. Make your predictions on the materials that smash the easiest and which ones hold it together in the freezing conditions.
Welcome back to Mods. I'm Brady.
I'm Lan.
And if you know anything about what we do, you know that we love playing with liquid nitrogen.
Yes.
And one of the main questions we get every time we have liquid nitrogen out, whether we're making ice cream or doing our regular experiments, is, well, what would happen if you put this in liquid nitrogen? What would happen if you put this in liquid nitrogen? Will it freeze and will it smash like glass? So today, we're going to try to answer some of those questions. We have a table full of random stuff.
Random!
And we're going to throw them in the liquid nitrogen and see how they react, see if they smash or not. So, you want to get started?
I'm ready to smash it all.
So let's see what smashes. Safety goggles on for this one. I'm going to start by giving us a little supply of liquid nitrogen. Liquid nitrogen, if you have forgotten, is the liquid form of our most abundant gas in the atmosphere. Nitrogen takes up about 75% of our atmosphere, and in its liquid form is 320 degrees below zero. So we're going to start off going big. Let's see what happens with this cantaloupe.
I'm not going home, I'm going big. Here we go. And I can touch it. Oh yeah.
So flowers are coming through. It's really adding a nice aroma to our bouquet of frozen smashed fruit. So let's maybe see what happened to our flowers here. You want to just give it a crunch. And now we have flower confetti. So we learned a lot about liquid nitrogen and how different things react to that. And hopefully we'll get to do it again soon, and hopefully you tune in next time.
Thank you for joining us for this episode of Virtual Camp Discovery. Special thanks to Citrix, Mod's official innovation partner, for powering this series. Please stay safe and connected with Mods by visiting our social channels at MODSFTL. Hi, and welcome to Mods. We're keeping you connected to inspiring science with virtual Camp Discovery, brought to you by Citrix, the museum's official innovation partner. Let's set sail into the Florida Everglades to meet a baby American alligator. Hey, welcome to the Museum of Discovery and Science. I'm Michael. I'm here in our Ecoscapes exhibit, right outside the alligator hole. Some pretty cool animals inside of here. I just really wish I could see one up close and personal. Oh, wait.
Ooh. Did you call for personal experience?
I did. That was so crazy.
Here I am.
What are you holding?
This is Beast Boy. He is our baby American alligator.
He's really small. How old is he?
He is roughly between 3 and 6 months old.
That's fantastic. Where does he live?
He lives within the Everglades. He's a Florida native.
And the Everglades, it sounds kind of like an important spot.
Yes, it is one of the most important places in Florida and the world.
Why?
Well, the Everglades is one of the most diverse ecosystems on the planet. And it is the home to an abundance of different animals, and it is very important for where we get, us Floridians get all our water.
And so the Everglades can be very hot, so I
Yes.
assume it's dry all year long there?
No, here in Florida we have 2 seasons. We have the rainy season and we have the dry season.
And when are those?
Well, the dry season would be considered winter. That would be from November to April, and then the wet season would be from May to October.
Awesome. And so now I'm looking at this baby alligator, beast boy.
Beast boy.
And he has some stripes on him. Why does he have those stripes?
Well, as he gets older, you might notice that adult alligators don't have these stripes, but as babies, he is very tiny. The Everglades is filled with abundance of animals he'd make a wonderful snack for.
Okay.
So these little stripes help him camouflage within the sawgrass and the reeds, so he is not easy pickings.
So camouflage is kind of like him playing hide and seek.
There you go.
Okay, fantastic. And is he native to the Everglades?
Yes, he is. He's one of the keystone species of the Everglades.
Keystone species. That's a very big phrase. What does it mean?
A keystone species is essentially an animal in an ecosystem that determines and reflects the health of that ecosystem.
Awesome. And you said he was native, so the opposite of native, I'm going to assume, is non-native?
Non-native or invasive.
And what is an example of a non-native or invasive animal that might be in the Everglades, let's say today?
One of the biggest threats to our little guy here and the Everglades as a whole is like the Burmese python.
But that's a snake. Don't we have snakes here?
Yes, we have our native snakes, but the Burmese python actually comes from Asia and India.
Oh, so they don't live here.
No, they can grow
Okay.
up to 20 feet long. And these alligators are supposed to be the biggest thing in the Everglades.
So last question I want to ask you. He's croaking. Why is he croaking?
Well, alligators are typically raised by their mother for the first couple months of their life. He is croaking to call his mommy over.
Oh, okay. And does he ever call daddy?
No, does not play a role here.
Okay,
all about
fantastic. Well, thank you for that up close and personal experience with an American alligator. We'll see everybody next time on our YouTube channel. Thank you for joining us for this episode of Virtual Camp Discovery. Please stay safe and connected with mods by visiting our social channels at MODSFTL. Hey, welcome back to the Mods YouTube channel. My name's Michael. Today we're gonna make chocolate slime. Hey, welcome back to the Museum of Discovery and Science. We're in our hangar again. We are joined by our CEO, Joe, who's come down. He wants to make slime with us. You've done this before though, right? Didn't you start as an educator at a museum?
I used to be a museum educator, and I love nothing more than doing this, playing, and it's so fun to be able to be here with you.
So today we're gonna make a chocolate birthday cake slime. So we're gonna really add a whole bunch of different things. Now, as you can recall from some of our other series, we have made lots of different kinds of slimes before. Here's one of our examples. But today, Joe's going to lead us in his chocolate slime. So I think the first thing, you're also a fan of it, the clear glue.
I do. I like the clear glue. We're going to start with your Elmer's clear glue, and start small, do a little bit first, and see where we go.
So remember, like he just said, start small. We always want to start small.
Think a
You
bit more.
always want to, go a little bit more on that. I love it. Perfect.
There we go.
So you want to start small, and you want to add just a little bit and let it work. You never want to add just crazy amounts, because then you're not going to be able to get there. So I think the next thing we're going to add in here is let's go with our shaving cream. So we want to give this like a fluff. We want to kind of give it that cakiness to it. So we're just going to add that right on top there. And we're going to, okay. All right, we're getting some, there we go.
There we go. Nice and fluffy.
So we've got the shaving cream in there. That's going to give it the fluff. Now, of course, we need the chocolate. I think we're going to leave activator for the end. So we're going to add the chocolate in there. And this is just a sprinkle to give it some color, to give it some smell. This is going to be one of those slimes that is going to have a smell. It's going to have a distinct color and not a flavor, because one thing we don't want you doing is eating your slime. That is just not something we condone. Please don't.
I'm smelling. It smells like chocolate.
So now we're just going to give this a mix. We're going to mix this together. We're going to make sure everything is mixed well, so that when we do add the activator, the activator is going to bring this together and it is going to give us the slime consistency that we're looking for. So now as you can see, this almost has that same look of, you know, mom or dad making a chocolate cake or making chocolate cookies. We don't have the chocolate chips in there, but we're gonna add something a little bit later to kind of give it that confetti look. So I think we're ready to add our activator. Right? I'm gonna help you out with that.
Thank you, Michael.
I'm gonna come over here and we're just gonna add a little bit of activator. Oh, that chocolate smell
smells great, right?
Right there. So here we go. We're gonna add.
Here we go.
Starting here. And as you can see, he's working the slime in circled patterns. We kind of realize that that is a good way to really grab the slime and bring it all into the middle. It's never going to be, we may need some more in there, but it's never a good idea just to go crazy and start going in up and down patterns or side to side patterns. So here we go.
Oh, that's getting nice and
we've got our slime working really nice. Another good thing to remember is before you do slime, wash your hands. Make sure your hands are clean because it's really going to pull everything off your hands. You don't want to share that with anybody else. Second, make sure you wash your hands after the slime. And like we always stress, you don't want to put this down the drain. So you want to make sure you clean it off as much as possible. And one thing we want to remind our viewers is before you make your slime, make sure you wash your hands because whenever you make slime, it's going to pull everything off your hands, even rings, jewelry, that kind of thing. The other thing is wash your hands afterwards. We don't want you putting slime down the drain. I mean, you're having a ball here. So just make sure that you're being safe and you're being using common sense when you're doing this. Now, the last thing we're going to add to our slime, we really want to just give this some sound, is we actually have these micro beads right here that you can order offline, and we're going to just pour these right into the slime, and as you can see, we're kind of getting that fun.
Nice. This is just like the chocolate crunchy birthday cake.
Now I just need a bacon half cake, right?
No, this is it's more cooking than I've done in a while.
So just make sure, remember, we're not eating the slime, we're having fun. We've got a nice chocolatey aroma to this, and this is something you can have for days. This is something you can store in a container and you can work and have for many days to play with. Never play with it on the carpet, but always enjoy it on a nice flat surface with mom, dad, brother, sister. Well, thanks for joining us. I hope you enjoyed making chocolate slime with us. Thank you, Joe, for joining us.
Thank you, Michael.
Everybody have a good day. Bye.
Thanks, everyone. Bye.
We want to thank Truist for sponsoring this video today. If you liked what you saw, make sure you subscribe below. Hi, and welcome to Mods. We're keeping you connected to inspiring science with virtual camp discovery, brought to you by Citrix, the museum's official innovation partner.
Check out this explosive weather demonstration as we create a Nitro Cloud. See what happens when liquid nitrogen meets hot water. Kaboom!
Hey, I'm Brady.
I'm Lan.
And we're here at the Museum of Discovery and Science, and we're going to be making our Nitro Cloud today. So usually when you see clouds in the sky, that's a lot of moisture that's been evaporated from the water cycle and is collecting in our atmosphere and collects enough until it condenses and packs into these tightly formed clouds. And when other forces like temperature or pressure makes that release, that's where rain comes from. For us today, we're going to be making a cloud using some pretty powerful chemicals in one of our classic experiments here. Now, Lan, what do we have in front of us here today?
We have two different liquids here. We have our liquid nitrogen, which is negative 320 degrees. It's so cold that it feels like it's burning you. And we have some hot water here. It's really, really hot. I want to say how hot?
I'd say probably like maybe a little over 100 degrees, 120 degrees or so.
All right, and I'm gonna add these two in together. First, I'm gonna add my liquid nitrogen for about 10 seconds. Then I'm gonna add my hot water. And from there, what do you think is gonna happen, Brady?
Well, let's see. So he's gonna pour in the liquid nitrogen now, which is the most abundant gas in our atmosphere, right? It takes up about 75% of our atmosphere. It's pretty inert, it doesn't really react to much, we don't smell it, we don't really feel it, but when it gets cold enough, about 320 degrees below zero, it turns into liquid. Those molecules condense and pack in tight enough to become a liquid from a gas. There's no real solid form of nitrogen because, again, it takes 320 degrees below zero to get it to become a liquid. And that's almost at absolute zero, which is the absolute coldest temperature where all molecular movement stops. So the water, which is about 400 degrees hotter than the liquid nitrogen, is going to cause a really intense reaction when we mix the two together. Are you ready to go, Lan?
Yes, give me a countdown.
So we're going to go from 5, 4, 3, 2, 1.
Every time.
So we just formed a pretty intense cloud here, and it's kind of dispersing away. And again, this is just moisture from the water hitting with the very intense temperature of the liquid nitrogen, and that disparity between hot and cold and the moisture involved gives us this cloud, much like the clouds we see on our atmosphere, especially when a storm is about to pile up.
Thank you for joining us for this episode of Virtual Camp Discovery. Special thanks to Citrix, Mod's official innovation partner, for powering this series. Please stay safe and connected with Mods by visiting our social channels at MODSFTL. Welcome back to the Mods YouTube channel. We've got a treat for you today. Today we're going to watch the Kaboom Show.
And I would like to welcome everyone to our Keller Science Theater. I am Dr. Kaboom, and I'm here to give you a what? A kahoo? A Kaboom Show. Now, what is Kaboom? Kaboom is basically, we're talking about the study of states of matter, chemistry. Now, matter, you matter, I matter. What is matter? Matter is a solid, a liquid, a gas, and plasma. Now, we can find plasma in two forms: in our light that we see around here, and also in our handy dandy lighter. Now, when you go outside, you hear a rumble, you see a flash of lightning. Yes, that is correct. Lightning is also a form of plasma. Now, my question to my audience members. I have this piece of paper here. I would like to give it a physical change. Is there any way that I can give this paper a physical change? Okay, I can rip it. I can crumble it. For those of you at home, I know you're thinking, can take a bite out of it, take a bite out of crime. It's really good. It's not good for my protein digestion system. Any basketball players out there? We can play basketball with it as well. Now, also, if I fold it, that is a physical change. Now, do you guys see any water anywhere? My water's right here. I'm going to take my paper and dunk it in my water. That is also a physical change. Now, a chemical change. You guys might have been thinking, why don't you use your lighter? Your lighter can set it on fire. My lighter is also part of a chemical change. Now that my paper is set on fire, we're going to let it burn a little bit and dunk it out here with my water. And now I have this black substance all over my finger in paper. You guys know what this black substance is called? Maybe it starts with an A, an ash. It's called ashes. A word that starts with an S, soot. Anybody? Or, of course, carbon, our scientific term, carbon dioxide, monoxide. Which one was it? I don't know. Now, we're going to get into our next experiment. It's my favorite one. So we're going to put fire in our water jug. This is our fire party. Now, we have 3 ways to start a fire. We need a ignition source, we need a fuel source, and we need oxygen. Now, we have oxygen flowing through our jug. If I do like this, like so, give it a nice little shake, shake, shake. Shake, shake, shake. Come on, you guys. Come on, say it with me. Shake, shake, shake. Now, if I place a flame on the inside, what do you guys think will happen? I'll give you a good hint. It's the word behind me. Kaboom! No, it won't go kaboom. I just like saying kaboom. It'll go fire party. Let's try it. So, again, we're going to trap our oxygen in. Give it a nice little shake, shake, shake. Shake, shake, shake. Woo! And we're shaking. And on the count of 3, we're going to place our flame on the inside. 1, 2, 3. That was so cool. I'm gonna do it one more time for you. I'm gonna add a little special treat on the end of this experiment. Okay, this is not working. What, I have to do something different. Okay. So maybe I should follow my steps again. I'm missing oxygen. So if I trap my oxygen in, okay, maybe it should work now. Oh, I didn't shake it. Okay. I'm gonna shake it. Still nothing. I know what it is. I have to do all of these motions at once. So I have to trap my oxygen in, shake it all together, keep my oxygen and my liquid in here. And on the count of 3, it should work. We're going to try 1, 2, 3. Now, this is one of my favorite parts of this experiment. Now, imagine you're drinking your favorite beverage, water, drink out of a bottle. You're sucking all the oxygen out of your bottle. All your pressure is making your bottle implode. There's no oxygen getting on the inside. Now, as you take your lips off, take your mouth off your bottle, it should go back to normal. Now, I know you guys are just clapping and clicking that like button. So, we're going to keep these experiments rolling. Now, woo! Sometimes when you go outside, you might see something full of rust. I have 2 plasma spheres here, and they're covered in rust. Now, when I take these 2 plasma spheres and I smash them together, what do you guys think is going to happen? Yes, it's just like me meeting my wife for the first time. Sparks are going to fly. Are you guys ready? Here we go. Is that a puppy over there? Okay. I know you saw it. Okay, one more try. Nobody? Anybody? I should add some force. Let's see what happens when I add some force. I've been going to the gym, see if it pays off. Woo! Woo! All right. I think I got one more strong one in me like the Hulk. Here we go. There we go. Now what we have here is we have rips and tears all over our aluminum foil. Why is that? That is caused by our iron oxide being welded onto our aluminum foil. So every time you guys see a little spark there, our iron oxide is being welded on. We're going to do one more loud one. Cover your ears, guys. Cover your ears. Mom, here we go. Woo! That was so fun. Just going to set that to the side. Now, we have gotten to the part of our show where we do the kahoo, the kaboom. That is correct. Now, we've been practicing, we've been working out the kinks in our blast shield. Just give me a second. I'm going to rearrange my room really quick. All right. Now, here at the Museum of Discovery and Science, we have been constructing this special blast shield. This is shockproof, nuclear bomb proof. Nothing will happen. This is shatterproof. Nothing will happen to our audience. Nothing will happen to you guys watching at home. Okay? But if you have an Android, I think something might happen to you. I don't know. It's an iPhone Android joke. Now, here we have a balloon. Ordinary balloon. Do you guys know what it's filled with? If you think you know, go ahead and put it in our comment section below. Now, what we have in our balloon today, we have hydrogen. Hydrogen, which is the first element on our periodic table. It is not helium, it is hydrogen. Hydrogen is very flammable. And when we give this balloon a flame, it will go kaboom. That is correct. You guys have gotten the hang of it. Now, not only is it filled with hydrogen, it is filled with a very special, I don't know if you guys can hear that, we call that a salt base. And this salt base is called copper chloride. Now, copper chloride is basically things that are made out of copper. Things like a penny, the Statue of Liberty, copper wires, copper coins. Now, the Statue of Liberty was given to us a gift brown. But after the years of oxidation, or it oxidized, can you guys say the word oxidation with me? Oxidize. That means it's a method of change. It goes from rust or non-rust to rusty, like your penny would. Your penny would go from brown to green, or our Statue of Liberty went from brown to green after it oxidized. I know you guys are tired of me talking. We're ready for this kaboom. Are you guys ready? Clicking that like button lets me know that you're ready. Here we go. We're gonna get a nice kaboom going here. And you guys are gonna count down with me, starting with 5, 4, 3, 2. Woo! What color did you guys see? If you're like me, I'm a little blind, I seen blue. But if you're looking directly at the center of our blast shield, you saw green or turquoise color. You're looking anywhere to the top, you saw a hint of blue. Anywhere to the bottom, you saw a natural hydrogen-filled flame, which is orange. Now we have one more balloon here, and it is filled with a different salt base. Now, this one might sound a little different for you guys. Let me know if you can hear the difference. Tell me what you think that sounds like. The first one sounded like rice or maybe something grainy. This one sounds like it could be thick beads of sand. And for our final time today, we're gonna get our last kaboom. Are you guys ready? You guys can put me on live if you want. And we're gonna get another countdown starting from 5, 4, 3, 2. All right. I hope you guys didn't blink. If you blink, you saw black. What color did you guys see? I saw purple or a lavender color. What we had in our balloon was potassium, potassium chloride. You can find potassium in what? Bananas. And who else likes bananas? Our minions. Minions love bananas. Now, some other salt bases we might put in a balloon. We might put strontium chloride. Strontium chloride, which is found in coral reef and is also used to fight bone cancer. Cobalt, which is found in paint. It will turn the flame blue. And sodium, which is table salt, it will turn our flame yellow. That is all the time I have for you guys today. You guys have been phenomenal. Thank you guys for watching. Thank you guys. I'll see you guys again.
We want to thank the Florida Panthers Foundation for sponsoring this video. If you liked what you saw, subscribe below.